Okay, now we have adding and subtracting in scientific notation. All right, so like if we had 3.2 times 10 to the negative 7 minus 2.5 times 10 to the negative 6, I would know that this is an extremely small number, so it's going to be 0.00 something, and so is this. But if I'm looking at a number line, which one of these two is bigger? Well, it's the opposite of positive numbers, so this is actually smaller. And this number's bigger because it's closer to 0 on the number line. So if I'm subtracting them, that number would have to go on top. For example, if I had negative 7 and positive 13, which one is bigger? 13. So you would have to put 13 on the top, which was positive, and 7 on the bottom, which we knew was negative. And 13 minus 7 is 6. Okay, which would also be positive because it takes the number, that's up top. Okay, so negative 6 is on top. So how do I write this again from scientific notation into standard notation? Well, I'd have to move it 6 places to the left, make it small. Well, I have one number here. So that's 1, and then I'd have an additional 5 more zeros. So I did that here. 1, 2, 3, 4, 5, 2, 5. And then here I head to the negative 7, so that has to go on the bottom. And of course that one was a negative, and this one is a positive, and we're subtracting. All right, so negative 7, I have one number here, so now I need to add 6 zeros. 1, 2, 3, 4, 5, 6, and then of course the 3 was 7, and we've moved it over to here, the decimals. All right, when you add and subtract, remember you got to line your decimals up, which is what we did here, and then you subtract regularly. So I had to add a 0 to the end here, borrow from the 5, make it a 4. 10 minus 2 is 8, 4 minus 3 is 1, 2. And then I started getting a little off, so I was like, 0, 0. Okay, so I got this when I subtracted, and I said, okay, that's in standard form. Mathematicians are kind of lazy, y'all. We don't like all them numbers, so we need to make it into something that we can read quickly and efficiently. All right, so I count. It's a negative because it's a very, very small number. This is, the bumblebee's antennas. 1, 2, 3, 4, 5, 6. 6 places to the right will give me a number that is greater than or equal to 1. 2 is greater than. So our decimal will now be here. So that will become 2.18 times 10 to the negative, because very small number, negative 1, 2, 3, 4, 5, 6 places, negative 6. Very small number, negative exponent. Okay, well then I decided, that's all well and good. And of course, if you have a calculator, you can input all of this or this or this and get an answer. But without a calculator, which may be required at some point in your life, you have to know that adding and subtracting scientific notation is much like adding and subtracting like terms. For example, 4m plus 2m plus 3m squared plus 2m. All right, we have to combine like terms. Like terms would be a 4 monsters plus 2 monsters is 6 monsters. M squared, that's like a mega monster. That's not the same. Plus 2m. So 6 plus 2 is 8m plus 3m squared. Now, there's nothing I can do to combine those because they are unlike terms. That is your final answer when simplifying by combining like terms. Same thing with exponents. The only way to add or subtract them, now I can multiply these all day long. If you want me to multiply that, that'd become 8 times 3 is 24, m to the first power times m to the second power is m to the third. So if we're multiplying, yes, we could simplify it. But if not, you know, a lot of people try, but that's incorrect. This is actually the answer. So same thing with here. You have to have your exponents the same. That's right, just like terms. So I have -7 and -6. So I can either make this one bigger by 1, and to do that, I would have to make this one smaller by 1. Or I could make this one smaller by 1 and make this one, bigger by 1. So honestly, I know that I need one number up front, and it doesn't matter about the numbers that go after that. So this, if I make this one smaller by 1 and make this one bigger by 1, that wouldn't work. Okay, so I need this one actually to be bigger by 1. All right, so let's do that real quick. Let's see. So if I add 1 to this, what do I get? You know, this is complicated. Not gonna lie to you, I had to think for a second there. -7 plus 1 is, you borrowed 7, you gave 1 back, you still owe 6. So if I add 1 to this, I'll get 10 to the -6 times. All right, if I make this one bigger by 1, I have to make this one smaller by 1. Yes, that's right, smaller by 1. So I'm going to move the decimal place over 1 to make it smaller by 1. So now I have 0.32, 32 hundredths, 0.32. Okay, now I can function because these are like terms now. They are both to the -6 power. When I talk about like terms, that's what I'm talking about. They have the same, to add and subtract, they have to have the same exponent. Oh, equal sign. All right. Equal sign. All right, now what do I do with this? Same thing. I got to do 2.5, which is the larger number. That's negative. And subtract it from 0.32. Add a 0. Okay, borrow from the 5. Make that a 4. That becomes a 10. 10 minus 2 is 8. 4 minus 3 is 1. And we have a 2 here. 2 minus 0. Negative. All right, times 10 to the... Okay, we got them both to be the same, so they stay the same. All right, so when adding and subtracting, you have to, 1, have the same exponent for both values. Values to the power of 10. Okay, so same exponent, and then you either add or subtract. Step 2, add or subtract the numbers before the 10. All right, let's try another one. 3.2 times 10 to the third plus 4.5 times 10 to the fourth. Okay, make this one either bigger by 1 or make this one smaller by 1. I'm going to make this one smaller by 1 because that'll put that to 0.45, and I would still only have one number in front. So, I mean, you could do it either way. I could make this one bigger, but just from experience, looking at it in my head, if I subtract 1 here and make this a 3, make that smaller by 1. Oh, I'd make that one bigger by 1. I don't want to do that. I don't want to do that. Scratch that. So let's make this one bigger by 1. Yes, that's the ticket. Bigger by 1 and smaller by 1. 0. 0.32, okay? All right, so scratch that idea. What was I thinking? I got confused. Okay, so now we have smaller by 1, bigger by 1. We have 0.32 times 10 to the 4th, or 0.32, plus, we're going to leave this one alone, 4.5 times 10 to the 4th. Are the exponents the same now? Yes, they are. Did we make them the same? Yes, we did. I added 1 here and made that smaller. If I would have made that one smaller by 1, I would have had to make that one bigger by 1, which would have made 45. So 45 is not scientific notation, but 4.5 plus 0.32 is going to make scientific notation. So that's precisely what we do. We're just going to add 4.5 plus 0.32. Add our 0 up here. And you get 2, you get 8, and you get 4.82 times 10 to the 4. Made that bigger by 1. Made that one smaller by 1. Smaller by 1. Stayed the same. Times 10 to the 4th was both of those. So final answer is 4.82 times 10 to the 4th. That is written in scientific notation. There's only one number before the decimal place, and that number is greater than or equal to 1. And if I wanted to write it in standard form, very large number, 2 places over would give me 482, and then I'd have to move another 2 places. So 408, 2, that's 1, 2, 3, 4 places. That will give me 48,200 in standard form. Both answers are correct. They're probably looking for this one, and it probably will not be as difficult as this one. Sometimes one's difficult though, and you'll get some that are not just adding 1 or subtracting 1, but you may have to add 3 or 4. So let me know if you have any questions on that. I know there's additional videos on the internet machines, on the U of the tubes. So let me know. Thanks.